go. Camera is now on. Hey. Alright. Hello, everyone. How's everybody doing today? Hey, Miguel. Hope everybody's doing well today. We'll get started here in a few minutes. Hey, Ivan. Yeah, Miguel, I'm doing pretty good. Doing pretty good, my friend. It's been a nice day today. Hey, Ivan, how are you doing today? Gustavo, hello. How are you? Bit nervous? Struggling with electronics? Oh. Is it the logic circuits that are giving you trouble? Ah, I see. Actually, I'm assuming you're talking and, or, nor, XOR, right? Not gates, things like that. Oh, intro to electronics. Oh, okay. Because if it was talking about logic, logic circuits, I was teaching a little bit about logic. Yeah, well, it depends. I'm not sure what totally entails. Ohm's law, okay. Ohm's law is more along the lines of, yeah, the math there. Actually, you'll like today then, Ivan. I can guarantee you. We'll get into that algebra aspect that may be helpful for your class. I don't know if it'll be completely useful, but it'll still be something, so. I hope so too, man. That's what I'm trying to do. Teach you something practical that you can use on an everyday basis, or at least when you need it. All right, wait for a couple more minutes here, and then we'll go ahead and get started here. Oh, hello. Oh, well, that's not good. Okay. Man, I'm gonna need more of those. Probably need to go to the store and buy more bulbs. I keep having them kind of burn out. Such a bummer. Oh well. Soon I'll have no lights available. Soon this screen will be like all dark and stuff, you know, just that's all you can see. Dollar Tree has some good LED bulbs. Oh yeah, that's a good idea. There's a Dollar Tree right across, really close to where I live. Yeah, I should probably go there and go grab some. As long as it does the job, that's all that matters. In my main room here, I think I have 2 good bulbs left. Just 2. Alrighty. Alright, so we'll go ahead and get started here, and we'll work our way up. That's okay. No biggie. No big deal. Alright, let's do it. Alright. Okay, let's get started today. Welcome back to Wednesday. End of the week time today. So today, we are going to continue moving on here in the textbook. Last time we finished all of chapter 6. All right, so that took us a majority of the time last time. Today, we're getting into chapter 7, okay, and kind of something that I mentioned here last time regarding chapter 7. We're going to skim parts of chapter 7. So I'm not going to get into too much detail regarding certain parts of chapter 7, and certain other parts will certainly get a good once-over, most definitely. All right, so let's go ahead and talk about each section here. Well, again, a couple of these sections here in chapter 7 are just like kind of really one and done type of sections, but some of them do hold very important points nonetheless. Alrighty, now the first thing that we'll need to do here is go right into section 7.1. So let's go ahead and do that right now. 7.1 talks about algebraic language and formulas. Alright. So the question for this is, all right, what are we exactly going to be looking for here in this chapter when it comes to algebra? Well, let's talk about some of the language that we see here in algebra that is just as important. The first set of languages, language we talk about in algebra is the word. Well, I do have a word. Just probably do this. Okay, is going to be the word a term. Okay. We talk about a term in algebra. A term is just a single expression. Okay, so for example here, what is a term? A term could be 5x, or 2y, or 7x 7x squared. That's a term, okay? A singular term. That can be literally a combination of anything, all right, with letters and numbers, but that's a term nonetheless. They also talk about the word factor. Factor is just a term that is in common between all of the terms which you can take out. Okay, so in this case here, a simple example of that would be, say, 5, let's say it was 5 times x plus y. Well, then in this case here, 5 is the factor. Okay, so no big deal. It's just something you take out, and that's it. So anything on the outside like this could be 5y, 5x, 5z, whatever. I don't really care. But that whatever you can take out, that would be in common between both of X and Y there. All right, so those are some terms there. Now, really, outside of the language part, which we'll certainly explore more here in this chapter, and I know it's, like I said, seems like I'm kind of skipping stuff here. Let's talk about what the real important meat and potatoes is going to be in this chapter in its entirety, and that's going to be the formulas part, okay? So a lot of these problems here specifically have formulas that are going to be given to you, okay? So what you're going to be doing here is, let's talk about the key here. Key here is you're going to be given a formula, and you will be asked to find for the missing variable. Okay, so you'll have stuff to plug in into that particular formula, and then you're going to be asked, okay, what is it that we need to solve for? And then we solve for that remaining variable at the end of the day. Okay, so that's how it's generally going to go here in this particular case. So we're going to look at a lot of word problems here where it's just going to be kind of plug and chug, but very importantly, again, solving for that one variable that is going to be left over that we need to get an answer for. So there's going to be a second key to this due to that fact that we're given a formula. The second key is to know what each letter in the formula means. This is really important because some questions, maybe not just in this section, but in other sections, some questions intentionally throw you off. How do they do that? Well, they may put that letter or variable in a different context than what is written necessarily in that word problem. So for example, that problem could be written as, okay, this variable is supposed to be in inches, but then they give you a dimension that's in feet. And then you're like, oh, okay, you kind of think, oh, I got to plop in just that number directly. No, you don't do that. You actually go ahead and actually have to convert those feet into inches and then plug it into the formula. So you have to be very careful. Know what each letter in the formula means and its proper units. All right, so very important here in this particular chapter and subsequent chapters as well. All right, so there's a lot of different, again, a lot of the first beginning problems here in the book just refer to, again, the formulas here, but I'm going to go ahead and go straight to the word problems here. We're going to go ahead and try some of the examples here, and we'll see what we get. All right. Just a second. Okay, so here you notice they have some formulas here. They ask you to plug those numbers in. We're going to put in one more tip here once we do a word problem here. Okay. All right, since Ivan was talking about Ohm's law, we're going to do an Ohm's law problem. Yeah, look at that. Irony at its best. All right, let's do number 2. Okay, let me zoom in on this so it's a little easier to read too. Okay. All right, so the current in amps in a simple electrical circuit is given by Ohm's law, which is I equals V over R, where V is the voltage and R is the resistance of the circuit. Find the current in a circuit whose resistance is 10 ohms that is connected across a 120 volt power source. Okay, so let's go ahead and give this a try here. Okay, and we'll go ahead and use Mr. Paint tool here for this one. Okay, so what we want here, again, is to go ahead and we're going to define each one of these variables here. Okay, so I here is going to be the I here is going to be the, in this case, let's see, where is it? Oh yeah, okay. So I here is what we're trying to solve for here. Okay, so we're trying to find the current, all right, in amps in a circuit whose resistance is 10 ohms and the voltage being 120. So let's, again, if you need to, you always write this out so you know the context of each letter. V for voltage. R for resistance. Okay, and I is going to be the current in amps. Okay, so here, let's go ahead and plug in the numbers here appropriately. Okay, so what number should we put in for V? What should we put in for V based on this problem? 120. I agree. I have 120 watts, so okay, 120. So I'll put 120 here. What about our resistance? That's correct. So this is 10 ohms. Okay, in this case, so 10. So we just divide. So we do 120 divided by 10. Let's scratch this. And what do we get? 12. Good. So our final answer here is 12 amps. Any questions about that so far? Ivan, I hope that helped you a little bit. This is burned in. You're like, it has to be. Burned in. Very good. Very, very good. All right, let's try another problem here. Let's see, which one do I want to do? Several of them. Okay. That one's okay. All right, let's look at number 14. Yeah, 14. Okay. 14 is an HVAC problem. Okay. So it says the hourly heat loss, H in BTUs, through a uniform slab of material can be calculated using the following formula. So here they give you the formula. Okay, H is equal to A times the quantity Ti minus To, all divided by R, where A is the area of the slab in square feet. Ti and To are the inside and outside temperatures in degrees Fahrenheit, and R is the thermal resistance of the slab. Calculate the hourly heat loss through 672 square feet of walls with an R value of 19.5 if Ti is equal to 68 degrees and To is equal to 42 degrees Fahrenheit. Okay, let's go ahead and get started with this. Okay, I will have something important to point out about this problem. Problem by itself is not hard, but do have some important notes about this. Okay, first and foremost here, can you tell me how I should set up this problem? What should this problem look like if I plug in the numbers? What would this look like after plugging in the numbers? So I just want to see the setup here. Okay, so we have 68 minus 42. All right. All that over 19 and a half. Okay, what's our A? What's our A here? So I see your A there, Ivan, which is right, but well, there's our A there. 672. There you go. Nice. That's correct. So 672 here times 68 minus 42. Right. So again, we know that A here is the area of the slab, all right? So this is where context comes into play. If you feel like you're missing something here, take a look at what you have. In this case, you had 672 square feet worth of walls, aka the area of the slab in general. Okay, let's go back to this. Okay, so obviously for this one here, I fully expect you to use a calculator, all right? And does anybody have an answer for me here? $896. Okay. So the hourly heat loss here will be $896. And in this case, it will be in BTUs. Okay. Very good. Nice job, everybody. Okay. Not too bad. All right. Let's do another one here. One more. Well, actually, yeah, one more. Yeah, that one's okay. Okay, let's do this one here. There's one more here on this page I want to do, and that is this last one here, 17. 17, electrical trades. All right. An electrician uses a bridge circuit to locate a ground in an underground cable several miles long. This is the formula given here. So there are two versions of the formula. But the one you probably want to use is this one, where it's used to find x, the distance to the ground. Find x if R1 equals, and I know I'm kind of covering that up here, so let me go ahead and make that a little smaller to read easier. And boop. All right. Let's hope I can get this right. All right. Maybe not. Guess I'll have to make this a bit smaller. Okay. So find x if R1 is 750 ohms, R2 is 250 ohms, and L is going to be 400 feet. Okay, so the first thing I would like to see here in number 17 is the setup for the problem. Okay, so what does the setup look like here? What does this setup look like here in this case? Yeah, that's right. Okay. That is, that's correct. Okay, good. All right, so we have 250 times 4,000 So that part is right. And then that we have that over R1 plus R2, which is going to be 750 plus 250. Now, let me see something here. All right. Can anybody tell me what the answer is to this problem? What's the answer? Got 1,000. Okay. Anybody else? Maybe 1,000. Okay. So I'm just going to put here, maybe you got this answer, 1583.33 repeating. And you guys did a good job catching yourself here. It is indeed 1,000, okay, without question. All right, so that part is true. If you got this answer of 1583.33, the thing is that you have to be very careful about what you put in the denominator. Make sure to put parentheses here in the denominator since you're adding those two things together. All right, so put the parentheses in the calculator. If you're using like a graphing calculator especially. Okay, so that's what we have there. Yeah, just go ahead and put them in parentheses to separate them out. All right. Okay, so all right, there we go. Okay, good. Okay, good. All right, any questions about that? So that's pretty much what's going on in this particular section, yeah, is we're just talking about formulas, we're plugging in numbers, we're finding out what the value is going to be, and that's pretty much it. And then there's a ton of like word problems that you pretty much are doing the same thing over and over and over again. There's really, kind of no difference there. All right. Okay. Let's look at the next section here. So let's look at section 7.2. All right, section 7.2 is really, really small, really super fast. But there is one important part here in section 7.2, and that is basically talking about adding and subtracting terms. Okay, so the thing that we need to talk about here is the idea of like terms, okay? That's the only thing that really matters here in this particular case is like terms. Now, like terms are terms that have the same exact letters and the letters have the same exact powers. Okay, so the same exact letters and same exact powers. Hey, that's okay, Sono. That's not a problem. Totally understandable, my friend. Okay, so let's do some examples here, okay, of like terms. again, same exact letters, same exact powers. That's all we're really doing here. So, okay. All right. Okay, let's take this example here first and foremost. Let's try, how about 5x 5x plus 2x squared. Are these like terms? Yes or no? Can I combine those? 5x and 2x squared? Is that possible? No. Okay, that's correct. Okay, these are not like terms. These are definitely not like terms. All right, again, one has x, that's like x to the first, but if we could combine those, then this also has to be a 1. However, we have 2x squared, so that would be it. This is all you can really do. These are not like terms at all. Let's look at this one here. How about this? Are these like terms? Yes. Okay, good. These are indeed like terms. That is true. Again, the reason why these are like terms is that we have xy squared, and even though I wrote this as y squared x, again, you have the same y, you have the same power for y, which is 2, and you have the same x. So even though it's written differently, it doesn't matter. You know, with multiplication, you can flip stuff around if you want. So xy squared is the same as yx squared. No difference. So these are definitely like terms. Now, in this particular problem here, let's talk about what we have to do to combine these like terms. So, to combine like terms, we just add the numbers on the outside, and then keep the letter and powers of the letter. Okay, so that's all we're doing here. So what does that mean? That means here in this case, like for example, we have this. We just take 3 minus 8. 3 minus 8 is minus 5. And then we just keep the letters and their respective powers. And there you go. That's our answer here for this one, minus 5xy squared. Easy peasy. Okay, let's go ahead and take a look at another example here. This one from the book. That's not what I wanted. Okay, page this. Okay. So I'm on page 448 here. All right. Okay, so we're going to do a couple of these here really quick. Just maybe a one note or, yeah, a couple notes here to point out so you don't get kind of caught up a little bit in semantics. So the first one I want to do here is 22. So we have 4y minus 2 times 8 plus 3y. Okay. So let's do that one. Okay? All right. So now the question is, what do you think we have to do first in a problem like this? Negative 8 plus 3y. Okay, what do we do with that? Those are not like terms. So 8 and 3y are definitely not like terms because 8 doesn't have a y attached to it. All right, multiply what? Okay, so I'm going to stop right there for just a second, Gustavo. That's a good answer there, by 2. Now, the one thing that we need to be very careful about is going to be the note I'm going to put here for this, because this is one of those little tricky details. Okay, so note here, watch out for negative signs. Okay, this is important because in this problem here, as we can see, we have actually not a 2, but we have a -2 that we're going to distribute to both of these. Right. So we got to be really careful because the signs are going to change because we're distributing -2 and not +2. So that's kind of the thing that trips a lot of people up. So we need just to be aware about that fact. Now, if we take -2 times 8, then that's going to be -16. And we take -2 times 3y. Again, -2 times 3, positive 3 is -6. So we get -6y. Now all we have to do is go ahead and combine our like terms. So what are our like terms here in this case? All right, 4y minus 6y. Okay, good. And what's that equal to? -2y, good. So this is our final answer here, -2y minus 16. All right, one more quick one, and then we'll move to the next section. Which one do I want to do? Yep, number 30. That's the one. Had my eye on that one. So, well, actually, I want to do that one. Actually, 34. Actually, 34 is a. Thanking me. For what? What did I do? I appreciate the thank you, but I'm not sure what I did. You'll have to. Oh, for the educational content? Sure. Of course. Anybody's welcome at any time. Should you want to learn, then that's all that matters. The world is already harsh enough as it is, so having more knowledge can certainly help in the long run. Besides, I hope you learned something other than education. So hopefully you learn about life, liberty, and the pursuit of happiness. It's never a bad thing either. How to think for yourself, how to be independent. you know, think for yourself, the most important thing. All right, let's take a look at this one here. We got minus 5 times 2x minus 3x squared plus 2 times 9x squared plus 8x. All right, so we're going to distribute minus 5 to both of these and these two as well. All right, so if we distribute, can anybody tell me what we get after we distribute the minus 5 and the 2 respectively? Get k minus 10x is good. Just good start there. Okay. Okay. Plus 15x squared. Yes. And looks like you have plus 18x squared. Yep. And plus 16x. Okay, good. Okay, and if we add our like terms together, what do we get? So if we add up our like terms here, let's take a look at what our like terms are. All right, 3x squared plus 6x. Okay. Let's take a look here. So I got minus 10x and 16x. So I agree with this plus 6x here. Plus 6x is correct. Careful about the signs here, though. We have plus 15 and plus 18. Right, so that was, you're just missing a 3 there, Ivan. Instead of subtraction, it was addition. So it would be 33x squared plus 6x would be your answer for that. Okay. All right, good stuff. Okay, questions? Okay. Nope. Okay. Let's go ahead and move on. Okay. So the last couple of sections here, because that's the entire section really. Okay, so the last couple of sections here pretty much kind of go together, 7.3 and 7.4. And we'll go to, this is page 458. So essentially at the end of the day, what we want to do is in this section here in section 7.3, we talk about, I'll just go ahead and get that out right now. Section 7.3 is talking about one-step operations, all right? And section 7.4 specifically is two-step operations. Now, in all honesty, between the two, there's really not much difference outside of just the extra step that you have to take in order to get to your final result. However, regardless of if it's one step, two steps, or multiple steps, there is one thing that we do have to keep in mind. And this is the key to all of algebra here. The key to any one of these problems here is going to be, once again, the word balance. Okay? anything that we're going to do has to balance out appropriately. Okay, so if we don't balance things out, then that's usually what leads to wrong answers at the end of the day. Of course, we have to take into account the context of the word problem, but again, balance is going to essentially be the key here to pretty much every one of these problems in these next couple of sections. So we're going to go ahead and take a look at our balance here and see where we apply that in these problems. All right, so let's start off with something nice and simple, and then we'll just kind of work our way up from there. All right, let's do it. Okay. Okay, which one here? Okay. All right, we'll start off with yet another Ohm's law problem here. All right, so Ohm's law is often written in the form I is equal to E over R, where I is the current in amps, E is the voltage, and R is the resistance, like we talked about before. What's the voltage necessary to push a 0.80 amps current through a resistance of 450 ohms? Okay, now the key here in this case, again, we're given the formula like we were back in the first section. So it's like, okay, here's the formula, plug numbers in. But this time, we don't have necessarily all the numbers on one side of the equation to immediately solve. We may need to take an extra step to go ahead and solve for that last letter that doesn't have any value attached to it. So let's take a look here. So can anybody tell me, based on what we see here for our values, how can we set up this equation here for number one? How can we set up that equation with those numbers put in? Okay. Very nice, Ivan. That's correct. Okay, so that's right. We're going to have I, which is the current in amps, okay, which is going to be 0.80. Again, that's using our context here. I was in amps, so our amp current. E was our E is going to be the voltage, and again, R is resistance. Okay, so we have 0.80 equals E, because we don't know what the voltage is, over 450. That part is true. Okay, now the setup here is very important because now we have the numbers in the right places before we go ahead and do the calculation. Now, as is stated before here, the key to this whole thing is always balance. So because the key here is balance, we want to get E by itself. Okay, that's the goal here. If we get E is equal to some random number, and we don't care what that random number is, but we get E to some random number, okay, we're good. Okay, we get it equal to the number that it needs to be. So here we have 450, E over 450. This is, again, E divided by 450. But if we want to balance it out to get E by itself, we are going to, let's put that in purple, we're going to multiply by 450 here on the top. Why do I call math very dry on my page? A joke, yes? Math is incredibly dry, yes. Math is a subject that just takes, man, it sucks you dry. A lot of energy in math. It's a very, very dry subject for many. It's not a knock against the subject, it's just what it is. So if we multiply this side by 450, we're going to multiply the left side also by 450. Okay, so then these 450s will cancel out, which is what you want. And then you can plug that into the calculator if you like. 450 times 0.080, 0.80, sorry. And can anybody tell me what we get here? $360. All right, spot on. Okay, good stuff. Nice. And there's a 360 volts for this. All right. Good beans. Mathematics. All right. Let's do the next one here. All right. Okay, which one I want to work with? All right. So let's look at number 8 down here. So number 8 down here says, metalworking, the surface speed s in feet per minute of a rotating cylindrical object is given to us as s is equal to pi dn over 12. So let's go ahead and put that in the paint thing. Okay, and we're given here specifically, let's go to the next page here, because it does give us some values. D is the diameter of the object in inches, N is the speed of the rotation RPMs, and yeah, so pi will be 3.14 in this case, although I'm not a big fan of that. So D is diameter, inches. Okay, we have what we have here? Ah, yes, N is RPMs. Okay. S is FPMs. Alrighty. So let's go ahead and figure out what we're given here. So we're given an 8-inch grinder that has a surface speed of 6,000 FPM. What should the speed of the rotation be? All right, and you can round to the nearest 100 RPM. Okay, and we're going to plug in numbers here in this case. Now the key is that we're given 6,000 FPM, so 6,000 feet per minute. So here, if we're going to set this up, S will be 6,000. Let's make that 8. Okay. So we have 6,000 equals pi times the diameter, which is given to us as 8 inches, times N, which is the RPM of the object, divided by 12. Okay. Now, I'm not a huge fan of using 3.14 as pi, only because of the fact that it's not the exact value, and typically if we're doing things in the shop, we want something that's definitely more exact than necessarily going to very few decimal places. In any case, let's go ahead and figure out what we need to do here. So we need to solve for n. That's what we need to do. Find out the RPMs of this particular object. So what can we do here in order to solve for this problem? You tell me what to do. Yeah. What should we do first? Okay, that's what we have on this side here. We got that. But I need to do an algebraic operation, because our goal is to get n by itself. I agree with that. I'll replace this with capital N if that makes it easier. That was terrible. Let's try the fountain pen. Maybe it'll be better. Yeah, that's okay. That's fine. There. Okay. So can anybody tell me, how can I get n by itself? What can I do? Let's go in small steps. Let's go in small steps. So let's take a look here. Let's look at our roadblocks, okay? So we want to look at our roadblocks and remove said roadblocks, okay? That's all we want to do. So if we're going to remove our roadblocks here, what we're going to do first is we're going to multiply by 12 on both sides. So let's just multiply by 12. That way we can get rid of the 12 because we divided by 12, right? So we're not multiplying by n to both sides. We want to get rid of anything attached to n. So that's why I'm saying, okay, you know what? There's a 12 there. I'm going to multiply by 12 because I'm dividing by 12. I got to multiply by 12 on the right-hand side. I got to do the balance. I have to multiply by 12 on the left-hand side. So what I have here is 12 times 6,000 equals 8 pi n. We're just thinking in terms of roadblocks. Get rid of the roadblocks, we'll be solid gold. Okay. Okay, so we have 8 pi n, we got 12 times 6,000 on the left-hand side. Okay, what do you think we should do next? What are our other roadblocks in the way? What are our other roadblocks? What are the things next to n? Let's answer that. You just type pi for pi, pi. Okay, very good. That's right, Miguel. All right, so you see we have 8 pi here, okay, next to n. So we want to get rid of those as well, and then n is going to be by itself. But since they're multiplied to n, we do the opposite. So we always do the opposite here. So we're going to divide by 8 pi. And if we divide by 8 pi on that side, balance says I got to divide by 8 pi over here as well. And then we're going to get an answer for n here after plugging that into the calculator. Oop, messed that up. There we go. All right. And so I get an exact answer here of 2864. I'll go 2 decimal places here, 79. Okay. Remember to put 8 pi in parentheses there, otherwise it will divide by 8 and it'll multiply by pi. And that's not what you want. You can also put these in parentheses as well. Any questions about that problem before we move on? Any questions at all? Again, type no in the chat. Type no in the chat if no. All right. No. Okay. Yeah, I gotta know when to move on because I don't know if people got questions because of the lag. So I gotta make sure that we roll with it well. How would you punch that in your phone calculator? Let's see. You have an Android, I'm assuming. I guess. Question mark. Sup, Diego? Yeah, you can. On my Android, there's a set of parentheses here that you can roll with. So you could put like parenthesis 12 times 6,000, close parenthesis, divide, and then open parenthesis. We got 8 pi, so 8 times wherever you can find pi here. Pi is usually a special function on the calculator. So let's see. I guess you'll have to use 3.14, but some calculators have something more advanced than that. So I forgot where it was. I could have sworn that it is on this calculator. Let me see. Yeah, actually it is on my calculator. You just have to kind of push. You just kind of have to push down here. So, oh, well, okay. Okay, so then I got the answer here. You got a different answer, yeah. So don't forget the parentheses. Parentheses are kind of important here, Gustavo. So you need the parentheses in the respective places. You put parentheses there. Oh yeah, that's a good point. Yeah, Miguel, you're right. I think you're definitely right about that. Yep, Miguel's definitely right about that. Absolutely, 100%. Cool. Thank you, Miguel. See, we all come together to help each other out. That works like a boss. There you go. Hey, hey. It's true. Anything to help and gelp. Both. Alrighty. So that's like that's like one-step problems. I don't know what gelp means. Maybe it's like gulping and helping at the same time. So like you're like, hey, I'll help you drink that. I'll help you drink that pop. You know, it's like an unopened pop, and you're like, you just snatch it away from your friend, and you just chug the whole thing down. It's like, yeah, man, it's so awesome. I don't know if you all have. I don't know if you have all. I don't know if you have that friend who always like. I don't know if everybody's got that friend who always skims off of you a little bit. Just like, hey, can I have this extra chip? Or hey, can you chip in an extra buck? Hey, what do you got? What do you got with you? What do you got on you? At the moment in time where they got nothing on them, and it's just like you give them a little by a little, and they start taking a little bit more, a little bit more. That's you. Hey, look. Okay, look. This is what happens when you're spending too much on your boy with your dime bags. All right, you got to get a cheaper rate and find a new guy. All right, that's what you have to do. You have to do it. You want to know the legitimate thing that I hear all the time is that when people take my class sometimes and then they hear me for the first time, They're like, oh my god, I thought you were gonna have an accent and everything. I didn't think you'd be like Midwest and stuff and be born in New Jersey or some stuff. It's like, Gualmar. Guaymar. You thought I'd be dry? I guess can't argue with that. Man, man, I don't know. It's just my history. We get when you have so much crap happen to you, you're just like, I just gotta laugh at crap now, because most of it's just unnecessary drama. However, maybe I could pose as a Walmart greeter. I could just be like Miguel or Gustavo or Ivan. I'd be like, they come in and I'd be like, hey, or gue, or hola. And you got to do it with like the subtle head nod. Hola. Welcome to Gualma. Bienvenidos a Gualma. Me and the 3 years of Spanish I learned in high school. I'll say if you're going to teach a subject like math, you got to have fun with it. Math is so boring without it having been fun. Give the class. I can't. I'm not fluent in Spanish. Now my friend definitely fluent in Spanish because his mom was from Ecuador, so he definitely knows the Spanish there. But voy a Guatemala. Oh my gosh. Yeah, that's what you ask. You like, Mama, ¿qué es this? Voy a Guatemala. Okay, I got it. It's like if I speak in Pakistani, which is Urdu. Ma, ami kidre. Oh, shopping. Okay. I think my aunt is the worst shopper in my family. So my aunt is by far the worst shopper in my family. 10 times out of 10. One time, all right, true story. True story. One time my mom and my aunt went shopping, right? And they walked into a TJ Maxx. All right? And they spent like 6 hours in the TJ Maxx just looking like through every rack, every cloth, everything. And my aunt, literally, I kid you not, my aunt walked out with nothing after 6 hours in the TJ Maxx. And this is the reason why I never shop with my family anymore. I'm like, I ain't going through that nonsense. No way. That's some BS right there. I mean, how do you do that? This said 6 hours in the TJ Maxx, and you get nothing. Like that. Oh my gosh! You might as well just put up a cot in a TJ Maxx and just sit there, man. Yeah, that's impossible. I can't do it. I'm a shopper that has to go in, get out, go back home. I'm like, I bought my stuff. I'm done. I don't want to deal with this crap anymore. And you're just like, You slap it down. But sadly, no. Sadly, no. Sadness. I would have walked out with half the store. I believe it. If you're a big shopper, yeah, I can believe that. You'd be like, searching for clothes and all that stuff. Be like, yeah, I totally believe that. Completely. Depends on the store. Yeah, of course. Of course. You gotta just depend on the store. Naturally. I agree. All right. Okay. The tool store is your weakness? That's fair. One of my temp jobs way back when was to work for Snap-on Tools. So, I've had a lot of jobs, guys. So, most of them being the temp variety, but yeah, I've had a lot of jobs. Yeah, back when I mean, this was a long time ago. I'm talking way, way back. No, definitely not. This is like way, way back. So, I worked there for like a week, and for that week, I was asked to like arrange the orders, via the inventory. You know, um, you had to like put the tools in the right spots and everything like that. We had like reams of paper of all the orders and stuff. Like I said, this is way back when, before you had like a centralized kind of better computer server to kind of put it all together. So all you had were these printouts, and then you just kind of had to rotate around the warehouse to kind of put the stuff away. It was just like rotating paperwork and rotating tools. It was just like, okay. It was kind of a pain. They had a really antiquated system. I would suspect that that's changed since since I went there. Alrighty, let's do the next section here. So that was just one-step problems. We're gonna do two-step problems. All right, let's do it. All right, so we're gonna get right into it here. And again, two-step problems just means adding one more piece of the puzzle. All right, so let's go ahead and see how we can go and do two-step problems here, and see how it works out. So shouldn't be too bad. All right. All right, let's do this first one here. All right, let's do number 3. Well, actually, no. I take that back. Let's do number 4. Number 4 is a pretty realistic problem. I'll show you why. Number 4, the formula A equals P plus PRT is used to determine the total amount of money A in a bank account after an amount P is invested for T years at a rate of interest R. What rate of interest is needed for $8,000 to grow to $12,000 after 5 years? Be sure to convert your decimal answer to a percent and round to the nearest tenth of a percent. So, this problem here, probably one of the better problems in this section, just because of how realistic it actually is and how applicable it actually is. And so let's go ahead and do this problem first. So, all right. So in this particular case, we're going to write down our formula here. A is equal to P plus PRT. Okay, and again, what's important here is P is the amount of money you deposit. So basically, P is what we call principal in reality. This is actually principal. This is the amount of money deposited or borrowed. Okay, R is the interest rate in decimal. All right, T is time in years, very important. And A is going to be your ending amount. Okay, let's talk about this here for just a second. Okay, we have a few numbers that we need to put in here. Okay, so let's at least define what each of these numbers here. So can anybody tell me what would P be equal to? How much money did we deposit in this case? 8,000. That's right. So we deposited $8,000. Okay, how much time is this money going to spend in this particular account? 5 years, spot on. So we're just going to put 5 because the context here is in years. Perfect. And what about A? What's A going to be? 12K, all right, fair enough. Do we know what R is? Do we know what R is? No, that's correct. We do not know what R is. That's what we're trying to find. Now let's put it all together. Let's put our numbers in here. Let's see what we get here. All right. Okay, so we're going to have 12,000 equals, in this case, P, which is 8,000, plus 8,000 times R times 5 for the PRT part. Now, what we can do here first, really quick, is to go ahead and just multiply 8,000 times 5. That's actually pretty easy. So you can do that via the calculator there. No problem. So if you do that out, that's going to be 40K. All right. Now our goal here in this problem is to go ahead and solve for R. Okay? We want to solve for R here. So in this particular case, we need to take 2 steps in order to solve for R. So we have a couple of roadblocks in the way in order to get R by itself. What's the first roadblock that we need to remove? What do you think? What do you think we'll need to do here? The 8,000, that's correct. Okay, now this is how it works, and this is kind of how it generally goes for a majority of things. In this case here, again, you want to get 40,000 R by itself, right? So we are adding 8,000. So what we want to do here is, let's go with, no, everybody hates that color. Let's go with light blue. All right, we'll go with 8,000. We'll go with tealish. All right. So we're going to subtract 8,000 here, but again, we go off of balance and we subtract 8,000 here as well. So we get 4,000 here if we subtract, and we end up with 40,000 R on the right-hand side. Okay. All right, so that's the first step there. Now we still want to get R by itself. So what do we do next? Okay, divide by what? Okay, good. Divide both sides by 40,000, correct. All right, so let's divide by 40K. All right, and what do we get for R here if we divide? Anybody got an answer for me? 4,000 divided by 40K? All right, 0.1, very good. So convert 0.1 into a percentage. What's 0.1 as a percentage? All right, 10%, very good. Okay, so if you recall, we talked about this little concept here. This is simple interest. We talked about this when we talked about, say, the check into cash places and whatnot, and why you should never go to those places. This is the same exact principle as what we had discussed before. So I figured, yeah, I should probably show that off just in case, you know, something that you've seen before. And again, still relevant for what we do. So definitely very useful. All right. Let's see here. All right, let's look at another one here. Let's look at another one. Okay, not that one. Boo on you and a pox on your mailman. All right. There we go. Okay. Let's look at number 11. All right, number 11 here. Automotive trades. The 2017 Mercedes-AMG E63S generates 603 horsepower at 5750 RPMs. Use the following formula to solve for the torque created at this engine speed. So horsepower is equal to torque in inch-pounds feet times the engine speed in RPMs divided by 5252. All right. So in this case here, can anybody tell me how they would set up this problem? How would you set up this problem for number 11? Okay, good, Ivan. That's correct. Nice. So let's go ahead and put that together here. So here we got 603 equals T times 5750. all divided by 5252. Okay. Okay, so in this case here, we have to solve for t. So what do we do first? All right, multiply by 5252 on both sides. That's correct. Good. Okay, so this cancels. So we're left with 5252 times 603. And then that'll be equal to 5750t. Okay, what's next? All right, divide both sides by 5750. All right. All right. And what do we get for t here? That's our answer. That's our final result here after everything's said and done. 551, good. Nice. Okay, good. Technically I could finish this, but, well, information dump is information dump, so these are pretty fast too anyway. All right. Not super cruel. All right. Alrighty, let's look at the next part here. Let's look at the next question here. This will be the last question here for the day. I'm just going to probably finish up the last couple sections of Chapter 7. I know we got a lot of time, but I figure I don't want to like put too much information down your throats. So, yeah, it's just basically doing a few more examples and really just moving into Chapter 8. So that shouldn't be too bad. We're on really good pace here, so I'm pretty happy with where we're at. Okay. Let's see here. Where's that last one? Okay. All right. Now, number 16. Number 16 is, all right. I remember asking this on one of my tests before, so number 16 is one of those that definitely comes up from time to time. All right. So I'll give you guys a few minutes here to try number 16. So I'll read this off here. It says, a student has a test average of 89.4 for the first 5 tests of the semester. What score would the student need on the 6th test in order to achieve a 90 for all 6 tests? All right. So let's give you a few minutes here to try that out, and we'll see what we get. So give you guys a couple more minutes. Got this course. Because I had a 101 class that was going to meet for 16 weeks, right? And then that got taken by one of the full-time professors. And then they gave this to me, and this was like right before the semester started. Like it was like a few days before. Yeah, because somebody else took the class because they had to fill in their hours, and I was like, oh, well, I'm down a class, and then they gave this to me, and I'm like, oh, wow, okay, and yeah, then you guys all got me through random happenstance. We got lucky. Sometimes when you roll the dice, sometimes it just turns up 20s. There's nothing wrong with that. I'm not the 20, maybe I'm the 18 or the 17 or maybe the 16 or the 15. You know, yeah, maybe the 15. But yeah, I'm glad I got to run into you guys. So I don't teach Math 097. Well, I mean, as you can clearly see here, I clearly teach Math 097. I teach Math 101. I teach, yeah, I teach all the Math 097s this semester. But yeah, yeah, it's crazy, right? Absolutely nuts, man. Absolutely nuts. Hey, thanks, guys. I appreciate you. Absolute craziness, man. Absolute craziness. Night, Diego. You have a great one, my friend. You guys feel free to ask me whatever you like. It's kind of like if you want to ask me something, that's fine. I don't mind. Sadly, I'm terrible at physics. Me and physics never got along due to that teacher at U of I. I'm sad. That teacher of U of I, man, he not only made me not like physics, but he made me not like PowerPoint from then on. Can I be a welding teacher? Whoa, whoa, whoa. No, no, no. Though I have tried welding before. But if you want the man, if you want the two men who know their welding, Scott, number one, and Carlos, number two. Those guys know their stuff. Scott and Carlos, man, those guys are amazing at welding. They're ridiculously legit. Yeah, Carlos Guillen. Carlos is legit, man. He is awesome. I love Carlos. Yeah, man, Carlos and I get along really well. Actually, I helped him out with a little bit of math this summer because he's also studying. So Carlos like, I need a favor. I'm like, okay, I'll help. Yeah, man. Like, if you ask Carlos about me, Carlos knows me. Yeah, okay, yeah, yeah. Carlos knows me like the back of my hand, probably by now. So I've taught 097 so many times now, but I mean, it never gets boring. It never gets boring. It's so amazing. Like, this is my favorite class at Harper, is to teach 097. People look at me and like I'm crazy, and then I'm like, you don't understand. 097 is the most practical class on campus. 10 times out of 10. I said, you could take that to your job, like, right away. I'm like, now that. Well said, Gustavo. Touche. Uh, I'm fine with teaching the misfits because I'm a misfit myself. Don't let the glasses fool you. Okay? Um, Again, my share of trouble at times, but, I go above board and I do what I have to do. That's about it. Just because certain things kind of go below the book. I try to keep it as above board as possible. Yeah. So the reason why Chapter 6 homeworks are all the way at the bottom is because a while ago, we didn't used to do Chapter 6. So uh, we actually neglected to do Chapter 6. So basically, we added it later on, like a couple years ago or so. So I made new homework assignments for Chapter 6 underneath there. So that's why it's all the way at the bottom there. So Chapter 6 was like more of a recent addition to what we wanted to do for our objectives. And I feel that, just getting a little bit of that pre-algebra in, even though it's short, you know, awesome won't do the homework. So are they optional? No, they're not optional. No. They are homework assignments you have to do. They are on the list of things to do. Okay? You guys got any other questions? Feel free to ask. Oh, oh shit. Oh, double shits. How do I grade the homework again? Each section is worth 5 points. So I'll take a look at the percentage that you got correct on each section, and I'll give you the exact amount of points based on that percentage per 5 points. So that's how I'll grade homework. So I try and be as fair as possible in terms of the homework there. Yeah, I want to be fair. So I have to be fair. It's important. very important to be fair. So if I'm not fair, then we have problems. And if we have problems, we have problems. All right. Good night, Gustavo. I'm going to head on out myself. Everyone, thank you very much for heading on out here today. I will see you all next week. All right? Do some homework, do some stuff. We will see you all later. Miguel, Gustavo, Ivan, have a great one here. All right? Everyone, take care of yourself. Good night, everybody. Have yourself a great day. I'll be back tomorrow. But you guys, I'll see you next week. See you Monday. Bye.